Okay, so members, now we have a question where it's we have to get the equation of a plane, but when we are given 3 non-collinear points in that plane, the question is how do we get that equation of a plane? Now the idea is about sketching. Always whenever you are in the vector problems, try to sketch. Now I assume now the question is find the equation of a plane contained with points A, B, and C. So these points are in the plane. Now, all you need first of all, the power vectors. The power vectors will give you the normal. Or if you have the power vectors, you can use the second method. So now, if I have these points, they are points. But you know that if they are points, I can get vectors between them. How? So if I join A to C, I'll be having a vector AC. So I'll be having this vector AC. If I join A to B, I'll be having a vector AB. So this, because these points are in the plane, it means that even these vectors are in the plane. And if I have these vectors, so these vectors are parallel to plane. And if I have two parallel vectors in the plane, if I cross them, I'll get a normal to that plane. So if I cross these two parallel vectors, the product will be a normal. And if this normal, we said if you cross two parallel vectors, you get a perpendicular vector to this. And if these are in the plane, and this is perpendicular to these two, it means that it's also perpendicular to the plane. So our idea, first of all, is to get this one. So it means that now I need two vectors. So I need the U1, but my U1 is going to be the distance AC. I mean the vector SC. So my vector SC will be, we say this will be OC, OA. Can you substitute? Now my OC is minus OA, which is, so that this one will be giving me 1, negative 1, 3. You can even, for you, it's okay for you if you use the BC. It's up to you. So to get my U2, I'll get AB, which is OB minus OA. These are vectors. My OB is 2, negative 1, 3, minus my, which is 1, 1, 1, which will give me, this will be 1, negative 2, 2. This will be 1, minus 2, then 2. Meaning that now, my normal dot U2, my normal will be given by that. But my U1 is with U2. And when you cross these ones, I showed you a simple method. You cross, you put a paper in it, you cross that. Then you start to be having a determinant of 2 by 2. So you cross there, you say, this times this, we shall be having negative 2. Not so, okay, then we work it sidewise. So this will be negative 2, then minus, this time this we have negative 6. So when I cancel, I'll be having the overall thing as a 4. When we now cross the second, we say when you cross the I, the J, the question will start with the negative. So negative will be 2 the major, 2 times this which is 2, now minus 3 times this which will be 3. This will be negative 1 plus the negative to give you a 1. When I cross the last one, you saw me having this time this negative 2 minus this time this negative 1, and so it will give you a negative 1. This is negative 1. And so we are getting our normal. So you can use any way of crossing. This is the method I use. So you can use your own method. So now, it means that now from my n dot r equal to n dot a, we just substitute. Say this one is x, y, z equaling 4. Then a point. We need any point on we can take this one. This one is the easiest to take. 1, 1, 1. So 1, 1, 1. So we have now 4x plus y minus z equal to 4 plus, we have no d in these ones. 1 minus 1. So that we have 4x plus y minus z equal to 4. The second alternative, or the second approach, is when we use the other one of r equaling to a point in a plane plus lambda mu of the vectors. So from here, we have your x, y, z is equaling to a. My a point in the plane chose 1, 1, 1. Then plus lambda u1. My u1 is here. 1 negative 1, 3, plus mu u2 is 1 negative 2, 2. So from there, we form equations. So the first equation will be x equaling to 1 plus lambda, then plus mu equaling to, this is equation 1. Then the second is y equaling to 1 to 1, then minus lambda, then minus 2 mu, equation 2. Then the third is z equaling to 1 plus 3 lambda, then plus 2 mu, equation 3. Now remember, we started the easiest to eliminate is the mu. So this time it has to eliminate mu. So you see, I'm going to say, you see these ones are having the same property. So I'm going to say equation 2 plus equation 3. If I add them, you see, I'll be adding now this plus this I have y plus z equaling to this plus this I have 2. This plus this I have plus 2 lambda. When I add this, it disappears. Then after doing this, we make lambda the subject. So y plus z minus 2. Then we divide by this 2, it will be equal to lambda. This is equation 4. Now still we eliminate mu using the other equation. So it's like in this equation, I need to multiply here by so that I can add these 2. So if you say equation 1 multiplied by 2, so it will be coefficient 2, then I add equation 2. And let's see. I'll be adding now 2x, I multiply here through by 2, equal to 2 plus 2 lambda plus 2 mu. Now, I'll be adding now, equation 2 is, so if we add, so we have 2x plus y equaling 2. This will give me a 3. And when I add it here, so I'll be adding, this is the lambda, please, not x, this is lambda. This plus this, I'll be adding plus lambda. This will disappear. Take this beside, we have 2x plus y minus 3 equaling to lambda is the equation 5. So you see that now, this is lambda, meaning equation 5 is equaling to equation 4. R5 is 2x plus y minus 3 is equaling to y plus z minus 2 over 2. This is over 1. We cross multiply. This will be equaling to 1 times. Bring y this side, you have 4 of x. So that bring y this side, it will be now 2y minus 1, which is y. Bring z this side, now it is going to become minus z equaling to. When I take 6 the other side, it will be now 6, which will give you 4. So you see the same answer. All the methods are going to produce the same answer. So don't forget to subscribe to the channel. I wish you the best. Sign out.